Okay, today we talk about section 7.3, and in this section we talk about more identities, the double and the half angle identity. Okay. So let's recall this. If I want to add two angles together and find their cosine, so the cosine of alpha plus beta, then what I need to do is I take the cosine of the first, which is the cosine of alpha, then the cosine of the second. I'm in the cosine, so we'll take the opposite sign, and then we'll take the cofunctions, the sine of alpha, the sine of beta. Okay. So this is our basic sum formula for the cosine. Okay. So now what if we wanted to ask ourselves, what about a double angle? So for example, the cosine of not just x, but now two x's. And is there a formula for that? Well, we can think about it in terms of two x's being a sum formula. We could take this cosine of now x plus just another x. Okay? So what would happen then if we apply the sum formula to the cosine? Right? Well, we'll have to take the cosine of the first, which is just x, and then always the cosine of the second, which is again x. Then we would subtract the cofunctions, the sine of the first and the sine of the second. So that's just applying the sum formula. Okay. Alright, well now this can be simplified because these are the same angle. So this just becomes cosine squared x minus sine squared of x. So the cosine of the double angle is the cosine of, can be written in terms of just the single angle now, cosine squared of x minus sine squared of x. This is our first form. Okay. We can use our Pythagorean identities, okay. But okay, now what we could do is that we could change this cosine squared here. We know, using the Pythagorean identities, the cosine squared is 1 minus sine squared. And then still subtract off the sine squared of x. And we would get a second form, which is 1 minus 2 sine squareds of x. Okay, so this is a second form. It's helpful if you only know what the sine of the single angle is. This one you'll need to know both sine and cosine. And also, we could look at it this way. The cosine of 2x's, we could leave the cosine squared alone, and then subtract. Okay, now I'm going to open up parentheses here, because sine squared could be rewritten as 1 minus cosine squared. The reason why I open up these parentheses is because there's a negative in front here that I need to distribute. So simplifying this, we have cosine squared minus 1 plus cosine squared, which will simplify to 2 cosine squared of x minus 1. And this is our third form. Okay. So for a cosine of a double angle, we have 3 different forms. It gives us a lot of flexibility in how we approach this. Alright, let's do the same thing now for sine and see if we can't come up with something. Okay. So remember, the sine of alpha plus beta was the sine of the first, which is alpha, always the cosine of the second, which is beta. We're in the sine, so we'll keep the same SIGN. And then take the cofunctions. So the cosine of alpha, the sine of beta. So now we're going to consider the sine of 2x's. And to do this, we'll use the same trick that we used in the last one, but the sine of 2x's has to be the sum of x plus x. Okay. And now we can apply the sum and difference formula. So we'll get the sine of the first, which is just x, always the cosine of the second, which in this case is also just x. Then we'll put in the same SIGN, and now we can take the cofunctions. The cosine of the first, which is just x, and the sine of the second, which is also just x. Now these are actually like terms because they're of the same angle. If you would like to see it, we can look at it this way. This is the sine of x, cosine of x, plus, and remember, multiplication will commute, so this is the sine of x, cosine of x, which is merely 2 times the sine of x times the cosine of x. So now we have this identity for us to use as well. And we can also do it with the tangent. So the tangent of 2x's, again, is the tangent of x plus x. So when we apply the tangent formula, remember it's the tangent of the first, which is x, plus the tangent of the second, which is also just x, over 1 minus their product, the tangent of the first, which is x, and the tangent of the second, which is also just x. And now we can do some simplifying. Okay? So that the tangent of 2x will be equal to, well, now these are like terms, so 2 times the tangent of just x over 1 minus tangent squared of x. Okay. So these are through some additional formulas that you'll need to know. Okay. So let's do an example with them. Alright, let's say that we know that the tangent of theta is equal to negative 3/4, and we're going to have to be told what quadrant theta is in. Okay. Theta is in 2. Let's go ahead and find all of the double angles. Okay. So we're given the tangent of a single angle, and theta is in 2, so an angle in 2 would have a rectangle like so. This is theta. The tangent is the opposite over the adjacent. Okay. Now the question becomes, what do we do with this negative? And to answer that, we have to look and see what quadrant we're in. And since we're in 2, the x's are negative. Okay. Alright, now this is known as a 3, 4, 5 triangle. You could solve it using Pythagorean theorem to see that 3 squared plus negative 4 squared is equal to r squared, or 9 plus 16 is equal to r squared. So r squared is equal to 25, which makes r equal to just 5. R will always be positive. Okay. So this is a 3, 4, 5 triangle. Alright, now let's find the sine of 2 theta. So the sine of the double angle, well, we have a rectangle that represents the single angle, and we know that we can write the sine of 2 theta in terms of the single angle as 2 sine theta, 2 cosine theta. So now we can just fill in 2 times the sine of theta, okay, Okay, well, the sine of theta, we can read from here. The sine is the opposite over the hypotenuse. Times the cosine of theta, which we'll also read from here, which is the adjacent over the hypotenuse. And now we can multiply across. If there was any canceling, we would do it, but there isn't any. So our denominator is 25, and 2 times 3 is 6, times negative 4 is negative 24. That's, or 24 25ths. We could ask ourselves about the cosine of 2 theta. Now, in this case, remember we have 3 forms to choose from. I'll just use the first form. Cosine squared of theta minus sine squared of theta. Well, the cosine is negative 4/5. That needs to be squared, and we'll subtract off the sine squared. But sine is 3/5. And now we can simplify. Negative 4/5 squared is positive 16 over 25. Minus 3/5 squared is 9 over 25, which is just 7 over 25. We can also think about the tangent of the double angle. And remember, that's going to be 2 times the tangent of the single angle over 1 minus tangent squared of the single angle. So this will be 2 times the tangent over 1 minus the tangent squared. And we were given what the tangent is. The tangent was given up top as negative 3/4, or of course you can read it from here. Okay, and now we can simplify. Alright, so this is like 2 over 1. Okay, so 2 and the 4 will cancel. So up top we have negative 3/2 over 1 minus negative 3/4 squared is 9 over 16. So this is negative 3/2 divided by 16 over 16 minus 9 over 16. Or negative 3/2 divided by 16 minus 9 is 7 over 16. Which, when we are dividing fractions, we can invert and multiply. And now we can cancel. 2 will go in here, 8. And 8 and negative 3 is negative 24 over 7. So now we can ask ourselves, now that I know all about this double angle, its ratios, in which quadrant does 2 theta lie? I know the single angle, we were given that is in 2. So the one way we can always determine this is we can look. Well, the sine of 2 theta is negative. 2 theta is less than 0. And yet the cosine of 2 theta is greater than 0. So if we remember our cosine, our quadrant map, if the cosine is going to be greater than 0, and the sine being less than 0, that would put us in 4. So 2 theta lies in 4. Right, so those are the double angles. There's also the half angle. And so let's look at how we would get to those. So what we know is that the cosine of 2x is equal to 1 minus 2 sine squared of x. We know this, okay, from before. So what happens if I want to solve this for sine? Okay, let's try that. Well, to do that, I'm going to need to subtract off 1. So I have the cosine of 2x minus 1 is equal to minus 2 sine squared of x. Now I'm trying to get to sine squared, so let's divide by negative 2. So on the right-hand side, we'll just have sine squared. And I don't like to have this negative down here in the bottom, so if I transfer it up top, remember I can do that. You can think about it as multiplying by a negative 1 over a negative 1. Okay. So the negative comes here. Now we're going to have to distribute that through. Okay. So we'll get minus cosine of 2x's plus 1 divided by 2 is equal to sine squared. Now I don't like the negative sitting out front, an additional commute, so let's flip-flop these to get 1 minus cosine of 2x. This just makes it a little easier to handle. Is equal to sine squared of x. Okay, now I want to think about things in terms of a half an angle. Okay. And right now we're thinking things in terms of a regular angle, a single angle, and a double angle. So this angle is twice as much as this one. Okay. So I can do a substitution here that says I want this angle to be twice as much as this angle. So we're looking for a half angle. So if I make this 1/2 x, this angle needs to be twice as much, which is just a single x. You wouldn't have to do this substitution, but now we clearly see that this is a half angle. And we can take the square root of both sides then to get plus or minus 1 minus the cosine of x over 2 is equal to just the sine of the half angle, which we usually just write as x over 2. We will leave the plus or minus in this case because what sign SIGN we pick will depend on which quadrant we're in. So we will keep the plus and minus for that sake. So this is the sine of the half angle formula. Okay, we'll need to know that one. Now let's do that again and try and find the cosine half angle formula. Okay, so remember that the cosine of 2x is equal to 2 cosine squared of x minus 1. That's another one of our forms. Okay, we're going to solve for cosine. So the first thing we have to do is add 1 to both sides. Will be equal to 2 cosine squared of x. Now we need to divide everything by 2. Which will leave us with a cosine squared on the right-hand side. And everything's fine in this case. 2x plus 1 over 2. No negative to have to deal with there, so we're fine. And now, let's see. We could write this as 1 plus the cosine of 2x. That's fine. We could do it that way. Then it looks a little bit more like the other formula because addition commutes. It's not necessary, but we could. Okay. Now again, we're looking for a half angle, and this angle is twice as much as this angle, so we'll do the substitution then. I need the angle in here to be twice as much as the angle in here. I'm looking for the half angle formula, so twice the half angle is just the regular angle. And now we can take the square root. Again, we'll have the plus or minus. And 1/2 x we can write as x over 2. Multiplying by a half is the same as dividing by 2. Okay. And we keep the plus or minus, again, because it'll depend on our quadrant. So this is another formula. I hope you have your flashcards going. Okay. Alright, so now we know the sine of the half angle and the cosine of the half angle. Okay? And we're going to look for the tangent of the half angle. Okay? So remember that the tangent of the half angle is going to be the sine over the cosine. So we're going to take this over this. Okay, so the tangent of the half angle must be equal to the sine of the half angle over the cosine of the half angle. So it'll be plus or minus. They both have plus or minuses, so we only need to write it once. 1 minus the cosine of just x over 2 divided by the square root of 1 plus the cosine of just x over 2. Okay, now we have to simplify this. Okay? And the next thing I'm going to do is remember that if we have the square root of a over the square root of b, we can write that as one great big square root of the fraction. Okay? So this is equal to plus or minus the square root of the fraction. The top is 1 minus the cosine of x divided by 2. That's our numerator. And the bottom will be 1 plus the cosine of x divided by 2. So just applying this. Okay. Now I have a compound fraction under here, and I want to simplify that. So that's equal to plus or minus. Now when you're dividing with fractions, you can invert and multiply. So we'll keep the numerator the same and flip the denominator. And now there's some canceling that can occur with those 2's. And we get plus or minus the square root of 1 minus the cosine of x over 1 plus the cosine of x. And this is our first form. So the tangent has actually 3 forms as well, so we're going to start from here and look for the second form. So we know that the tangent of the half angle is equal to plus or minus the square root of 1 minus the cosine of x over 1 plus the cosine of x. Now, in general, we don't really like to work with square roots if we can get away with it. So let's reapply the square root of the fraction and make that the square root of a over the square root of b. Okay. So this is equal to plus or minus the square root of the numerator, which is 1 minus the cosine of x, over the square root of the denominator, which is 1 plus the cosine of x. And you can ask, why would we do that? Well, now that the radical's in the denominator, I could rationalize, and I would get rid of that square root. Okay, so I'm rationalizing here. So now, also remember that if you have the square root of a times the square root of b, well, that's the square root of their product. Okay? So I'm multiplying here. So what I can write this as plus or minus the square root of 1 minus the cosine of x times 1 plus the cosine of x. Okay? That's our numerator. Divided by 1 minus, divided by 1 plus the cosine of x, that quantity squared. And we can continue simplifying. This is equal to plus or minus the square root. Now these are conjugates, so if we multiply them out, we'll get 1 plus the cosine of x minus the cosine of x will go away, and minus cosine squared of x. And that will be over, well, the square root and the squaring will undo each other, and we successfully rationalized this. Now I'd like for all of the radicals to be gone, if possible. So I think to myself, well, here I have a 1 and a cosine squared. I should be thinking of Pythagorean identities. So plus or minus 1 minus cosine squared is sine squared over 1 plus the cosine of x. And now we can get rid of the radical because the square root and the squaring will undo each other. So we have a third form that's plus or minus just the sine of x over 1 plus the cosine of x. This is our second form. Okay, so our third form is going to come from here. Notice I had two radicals, and I chose to rationalize the denominator. We also have a technique called rationalizing the numerator, where I would multiply and get rid of the square root of here. So let's start from that point, that the tangent of the half angle is equal to plus or minus the square root of 1 minus the cosine of x over the square root of 1 plus the cosine of x. So now to rationalize the numerator, I have to multiply by 1 minus the cosine of x. Alright. And now let's just do our algebra manipulation. I'm multiplying radicals, so this is equal to plus or minus the square root of 1 minus the cosine of x squared divided by 1 plus the cosine of x times 1 minus the cosine of x. Now the square root and the squaring will undo each other, so we'll have 1 minus the cosine of x up top. And down below we have the square root of 1 minus cosine squared. And we'd like to be rid of this radical, so we can do the same trick using the Pythagorean identity, that 1 minus cosine squared is sine squared. And now we are finished. The square root and the squaring will undo each other. So our third form is plus or minus 1 minus the cosine of x over the sine of x. This is our third form. Okay, so let's do something that we know. let's do some examples and see how we could use the half angle. So one thing we know then is that, for example, we know that the sine of 30 degrees is equal to 1/2. We know this from the unit circle. Okay. Now let's find v as a half angle. Okay. So the thing we have to realize is that the sine of 30 degrees is equal to 1/2 60 degrees. Okay. All right. Now remember the sine of the half angle is equal to plus or minus the square root of, we have a 1, a cosine of just x, all divided by 2, and then we have to remember that it's a minus in here. Okay. Okay. So this is x over 2. Right. This is the single angle x. Okay. So this is equal to plus or minus the square root of 1 minus the cosine of 60 degrees divided by 2. Well, that's equal to plus or minus the square root of 1 minus, now the cosine of 60 degrees is 1/2, and we divide that by 2. Which is equal to plus or minus the square root. Now dividing by 2, let's just change this to make this a little easier for us. Dividing by 2 is the same thing as multiplying by 1/2. Times the numerator, 1 minus 1/2. Okay. Which is equal to plus or minus the square root of 1/2. And now simplifying this, 1 minus 1/2 is just 1/2. Okay. Well, that's just plus or minus the square root of 1/2 squared. And the squaring and the square root will undo each other, so we have plus or minus 1/2. Okay. Then we have to determine if it is the plus or the minus. And we know 30 degrees falls in the first quadrant, and everything is positive in the first quadrant because we're in 1. So you'll pick the positive branch. Okay, so that's how you do it with degrees. Let's do one in radians. Let's find the tangent of pi over 8 exactly. Okay. Now, your clue that you're going to need to be using some in different formulas or double and half angles is this is not an angle that we know exactly on the unit circle. Okay? So as soon as that's an angle that you don't know exactly, you need to be thinking half angles, double angles, sum formulas, difference formulas. Alright, so we know this. We know if we took 2 times pi over 8, right, that this would cancel and we would get pi over 4. Okay. 2 over 1 would cancel to get to 4. Okay. So what does that mean? Well, you can think about it 2 different ways. That is that pi over 8 is half of pi over 4. Or you can think, well, pi over 4 is twice pi over 8. So if you're finding this half or twice relationship, you should be thinking about this half angle formula. Okay. So we can pick, we're looking at the tangent of the half angle, and we can pick any of the forms, right? I'm going to use a form that only has the sign in the denominator and no radicals. Okay? So what is x over 2? That is pi over 8. Okay? This pi over 8 is half of just pi over 4. Okay? So this is 1 minus the cosine of pi over 4 divided by the sine of pi over 4. Okay? Plus or minus. Okay. Alright, so now plus or minus 1 minus the cosine of pi over 4, square roots of 2 over 2, and we divide that by the sine of pi over 4, which is square roots of 2 over 2. Now let's get a common denominator up top. We'd like that to just be 2, and well, 1 is 2 over 2. So it's 2 minus root 2 divided by root 2 over 2. Okay. And now we need to simplify. We're dividing fractions. So when you're dividing fractions, you need to invert and multiply. So this is equal to plus or minus 2 minus root 2 over 2 times 2 over root 2. Now these 2's are going to cancel, and we'll be left with plus or minus 2 minus root 2 over root 2. We don't like to leave radicals in the denominator, so let's rationalize this. So this is equal to plus or minus, now in the denominator, root 2 times root 2 is just 2. Now I need to distribute this through. So we'll get 2 roots of 2 minus 2, which now we can simplify as plus or minus 2 roots of 2 over 2 minus 2 over 2. Okay. Well, minus 2 over 2 is just minus 1. We know that. And now here we need to be careful. When you're canceling, you cannot cancel underneath radicals. Remember that. The 2's on the outside will cancel, and so we'll just be left with plus or minus root 2 plus, or minus 1. And now we need to determine the quadrant, okay? Is this a plus or is it a minus? Well, pi over 8 is a positive value. It's half of pi over 4. Pi over 4 is in the first quadrant, so this is in quadrant 1. We're in 1. Okay, let's do some other ones then that could come up. So that's just directly finding them. Let's look at this. Okay. Let's say, for example, let's say we know that the sine of the half angle is equal to negative 1/3. Let's say we know that. And then we know also that the half angle is less than 2 pi and greater than 3 pi over 2. And this is another way they could tell you what quadrant you're in. If they tell you this, this says that we're going in between 3 pi over 2 and 2 pi, so we must be in quadrant 4. Okay. So that value of the half angle lives in 4. Okay. Now, let's just find then what the cosine of x is equal to. So the cosine of x is twice as much as the sine of the half angle. So how are we going to do this? The sine of the half angle, this is twice as much. So the one we are looking for is twice as much as what is given. So let's use the cosine of 2x in this case. And remember, we have lots of forms. But since we're given sine, let's use the form where we know that it's 1 minus 2 sine squared of that. Okay. So in our case, what we're trying to find is 1 minus 2 sine squared of the half angle. Okay. This is twice as much as this. This one's twice as much as this. Okay. So that's equal to 1 minus 2 times, well, we have the sine of the half angle, and then we're going to have to square that. So the half angle is given as negative 1/3. So this is equal to 1 minus 2 times positive 1/9, which is 1 minus 2/9, which is 7/9. Alright, we could also ask ourselves then, what quadrant is x in? Okay, so if the half angle lives in the fourth, okay, so we have 3 pi over 2 is less than x over 2 is less than 2 pi. This is given. Okay. Now, if we want to find out just x, well, we can just solve this equality. I would need to multiply this by 2, this by 2, and this by 2. So in the middle, the 2's would cancel and we'd be left with just x. And now we would see then that x has to go in between 2 pi times 2, which is 4 pi, and it has to be greater than, here the 2's will cancel as well. We'll know that x can go between 3 pi and 4 pi. Okay, so that's actually a pretty big place for it to live. But those are the boundaries on x. Okay. Let's see. Let's do another one like that, but where we go the reverse way, because it's kind of can be a little confusing. Let's see. Now let's say that the cosine of 2 times theta is equal to positive 1/3. Okay. And theta is going between 360 degrees, or the double angle, 2 theta goes between 360 and 450 degrees. Okay. We want to find now the cosine of just theta. So what do we use? Do we use the double angle or do we use the half angle? And what we are trying to find is half of this. So we will use the half angle formula that says plus or minus the square root of 1 plus the cosine of 2 theta over 2. So this is equal to plus or minus the square root of 1 plus 1/3 divided by 2, which is equal to plus or minus the square root. Now remember, dividing by 2 is the same thing as multiplying by a half. And then up top, 1 plus 1/3 is 4/3. And now we can cancel here. This is plus or minus the square root of 2/3. Okay. And then we can split that up. Plus or minus the square root of 2 over the square root of 3. We'll do that so we can rationalize it, multiplying by the square root of 3. Will get us to plus or minus the square root of 6 over 3. And now we need to decide which quadrant this belongs in. Okay, are we taking the plus or are we taking the minus? Okay. So we come back up here to our 360 degrees. 2 theta has to be greater than that and less than 450 degrees. And now we can determine where just theta would lie by dividing everything by 2. So in the middle we would have theta less than or equal to, well, half of 360 is 180. And 2 goes into 4 2 times and into 50 25. So this places this in quadrant 3. Okay. And because we're in quadrant 3 then, we come up here and take the negative. We should probably do another identity where we verify an identity for our last one. So let's say we have to verify secant squared of the half angle is equal to 2 times the secant of the regular angle plus 2 over the secant of the single angle plus 2 plus the cosine of the single angle. Okay, so I'm trying to think about what we could do. It's always good to think out a plan through. If I use this, I would know that this is 1 over cosine squared of the half angle. I would have a radical in the denominator, but then it would be squared, so it would go away. And I could probably manipulate that to this. If I start here, I would be thinking about probably changing these to 1 over cosines, getting denominators, probably having to invert and multiply because I'll be dividing. I'm almost tempted to start on this side, so let's start with the left-hand side. You can pick whatever side you'd like. So the left-hand side is secant squared of the half angle. Well, we know that that is 1 over cosine squared of the half angle. Okay. Well, we know that's 1 over, okay, let's move that squaring out here so we can see this happen. The cosine is plus or minus the square root of 1 plus the cosine of x over 2. Now this squaring will undo the square root and the plus or minus, okay? Because anything once it gets squared will stay positive. So this will be 1 over 1 plus cosine of x over 2. Which if we invert and multiply this thing, that dividing by 1 divided by that, that's going to take the reciprocal, so we'll get 2 over 1 plus the cosine of x. Okay, at this point, there's nothing left to simplify in the numerator or in the denominator. There's no squares that I can get rid of, or I can do any substitutions. There's no way for me to write this as a fraction. I could write it over 1, but that's not really helpful. So when you're at a point like this and you get stuck, this is where we would want to use a technique of multiplying by the conjugate. So let's see what will happen if we multiply by the conjugate. Okay, so if I do that, I'm going to have to distribute that 2 through up top. I'll get 2 minus 2 cosine of x. There's a 2. I like that. There's a 2. I like that. This is not a secant, but we're getting there. And then multiplying by the conjugates, this becomes 1 minus cosine squared. Okay. Well, I know that 1 minus cosine squared, so I'll just leave this alone up top. 1 minus cosine squared is sine squared. I'm not liking this so much because I have 3 terms up top. So this would be equal to 2 over sine squared of x minus 2 over the cosine of x divided by sine squared of x. And now this is 2 times the cosecant squared of x minus 2 times, we could write this as the cosine of x over the sine of x times 1 over the sine of x. Okay. Because if I multiply these back together, I'll get sine squared on the bottom and cosine on top. So this is equal to 2 cosecant squareds of x minus 2. Now this is a cotangent, and this is a cosecant. And at this point, I want to stop and reevaluate what I've done, because I feel like I'm getting further and further away. We want secants and cosines, and I have cosecants and cotangents. So I could continue on with this method, but I think I want to stop and try again. Okay. Let's try a different method. I'm okay with this. Okay. At this point, I multiplied by the conjugate. Let's see what happens if I multiply by the denominator. Let's see what will happen there. So picking up at 2 over 1 plus the cosine of x, let's try multiplying now not by the conjugate but by the denominator. So multiply by 1 plus the cosine of x. Let's see what happens then. Okay. And so sometimes this will happen when you're doing identities. You just need to work it out and see how far you can go with it, and you may want to choose change methods. So here up top I'll get the 2 plus 2 cosine of x, which is good. I have the 2's. Again, this isn't a secant, but we're getting there. And then when I multiply this out, I get 1 plus 2 cosines of x plus cosine squared of x. And I'm a bit happier about that, because at least I have 3 terms, and this has 3 terms. Okay. Well, now, what are we going to do? Okay, so this is a 2, and this is just a single cosine, and this is a 1. So if I divided this by cosine, I would get a single cosine. If I divided this by cosine, I'd get 2. And if I divided this by cosine, I'd get secant. So let's try that. Okay. But I can't just divide the denominator, so I'm going to have to divide everything. So here's the numerator, and we'll divide that by cosine. And then do everything in the denominator. Okay. Divided by cosine. Divide by cosine, and divide by cosine. Alright, so 2 divided by the cosine of x is the same thing as 2 times the secant of x. Then here, the cosines will cancel, and I'm left with 2. 1 over the cosine of x is the secant of x. Again, the cosines will cancel here, and here I'll be left with 1 cosine of x. And now we've done it. This is our right-hand side, so we have verified the identity. Okay, so verifying identities is it's just a game. Just think of it as a game, and what can you do, and see what happens next. You will need to have good bookkeeping skills, though, and double check your work, make sure you're distributing properly and following the rules of algebra. Okay? Don't lose your angles, your x's or thetas or whatever angle that you're working with. Okay. So that should get you through your homework. If you have questions, send me an email.